In these videos, I'm going to go through all the great functionality we have in our enDAQ lab software for analyzing data. So to open a file, when you first launch the application, you'll get this splash screen with a few quick links to open, configure, and some additional resources. If you already have a file open, you go to File, Open. And I will open here a relatively large file. When I was doing some testing on a Ford F-150. It's 100 megabytes, so you might get this warning. You can disable this for future times. It will load the first a million or a couple million samples, and then as it finishes loading that, it starts to load all the other samples. And you see here, there's a couple things to look at. There's first, all these different tabs are the different sensor channels. So this is the orientation of the car as it's driving along. Here's one of the accelerometers. Here's the other accelerometer, the temperature, pressure, humidity, all that. Up here is a view bar of the time range, and you see these two little arrows you can be dragged along to zoom along the whole range here. You can also change your time range by defining your start and end time here. So I just want to look from time 50 to 100, and there you go. And if you just double click, I keep double clicking, so you can zoom in by just dragging and dropping your cursor, and then double click will zoom out, and you can also zoom out with a right click just a little bit. So I'm right clicking here to zoom out slightly, and a double click will zoom all the way out. A couple things to kind of pay attention to when you're looking at acceleration data. This is through the whole recording. How many samples? I'm sampling for 2 hours at several thousand hertz, so it's a lot of samples. And you see these kind of this envelope view where it kind of looks a little funny, and we get questions from that sometimes, like, why do I see these two lines? There should be just one line for my x-axis, y-axis, and z-axis. And what we're doing here is, because it's so much data, we're just showing you the max and min, the moving max and min. And if you zoom in, you'll see what you expect in kind of that shaded in acceleration data in that time range. You can see kind of, it's really light, but this shaded region is showing you the max and min there. Zoomed out, we only show you the max and min. Something else to notice when you're doing acceleration data, some accelerometers, like this one that I have open, can give you the gravity vector, so that 1g DC offset from gravity is desirable to see, but sometimes you're looking for vibration, you don't care about gravity, and you want to filter that out. Or in some of our accelerometers, like the piezoelectric one, they can't measure quasi-static acceleration, so you shouldn't be looking at the DC offset anyway. So if you want to get rid of that, you go to Data, Remove Mean, and you either remove a rolling mean or a total mean to get rid of that DC offset over time. So you see the oscillations about 0 in both accelerometers. A couple of things, what else to notice in the when you're looking in this view. Again, zooming is just a simple drag and drop. On the left hand side, you can kind of drag, click and drag up to kind of change the what max and min values you want to look at in the zoom. You can also drag and drop different channels. So if I want to grab this tab and pull it down here, I can do that to compare to the other accelerometer, for example, up here. I just right-clicked, that's why I was zoomed out. And again, you can keep doing that too. So if I also want to see the orientation data, I just grab that tab and pull it down, and now I can see these three views kind of stacked on top of one another. And then you can drag it up to get rid of that and get all in one view again. So that's kind of an overview of the general plotting area. Oh, there's a couple things here too. So down here on the bottom, you'll notice my cursor. So it's saying x-axis, y-axis, what the y-axis value, and the x-axis UTC time is. So that's just telling you where your cursor is on the screen, and that can be helpful. And you can also do you can move, I'm looking here, and the blue z-axis data is plotted first, and I can't see it because the y and x have higher amplitudes and they're plotted second. So I can change the order here by right-clicking in the legend. So I'm just going to say move z to the top, and then that pulls it out. You can also change the colors in here, which is kind of nice. I don't know what color I'll take it to. I'll do some. Oh, what do I do? I'll do orange. Who doesn't like orange? Oh, it's a terrible color when plotted against red. And I'll now change the red color to be something else. There we go. So you can do things like that. And you can remove a certain axis from the plot. You can change the legend position, play around with things like that. So that's the general plotting view. But now we'll go through some of these other areas here. So under the edit, you have preferences, and you can change a variety of things under the preferences, like if you want, every time you open the lab, if you want to see the open dialog, or do you configure your unit a lot, in which case don't always start the open dialog. You can play around with some of your preferences in there. Really though, you will want to play around in the view, where we can create a new tab, and you have to specify which type of units it is. So I have an acceleration tab, and I can say, all right, I want to plot the acceleration in the z-axis from the piezoelectric accelerometer, and I want to add the z-axis of the secondary accelerometer, and they line up nicely, which is good. What else do we have in here? You can play around with your zooming, and you can set the visible time ranges and the amplitude, which can be nice here as well if you're trying to get kind of a consistent view. That's the view. Now, that's kind of an overview of plotting. Now let's look at our data menu. As I showed you earlier, there's the ability to remove the mean, and I can't do that now actually because I have here. Cannot remove it if I want to see the DC offset. Again, the DC offset for the piezoelectric accelerometer is meaningless, so you should always remove it for that, but some of the other accelerometers have a meaningful DC offset. You can also change the units in here. This is helpful especially for pressure data. Where'd my pressure data go? If you want to convert this to altitude in feet, that's helpful. In temperature, us in the United States still like good old imperial units. Want to change this to Fahrenheit. Now you can see what happened there. You can play around there. And something else you can do is you can edit the calibration polynomial. This is kind of an advanced feature, so don't go too crazy. But if you know you want to change how the data is plotted, or how the raw data is converted and calibrated, you can do that here. This can be helpful when you're maybe recalibrating your device, so you can edit the calibration polynomials from a file you took that it should be something, and you can set it here and make sure the values come out appropriately, and then you can export this and import it as a calibration parameter, or set it when you're configuring a device to edit the calibration. So that is an overview of plotting. There's a lot in there. Please don't be afraid to reach out to us and get a quick demo and to go through some data that you have. And also this is available to download for free, So we encourage you to do that with some example files and play around with the capabilities and the plotting view. Thanks.